Welcome to our very first video looking at pseudoscience and science. Today's topic is believers and skeptics. Can we truly know reality? Now, there's not very many statements that I feel comfortable making that I would say most people agree with. However, there's one statement that I think most people who click on this video would agree with me on. People believe in some strange and weird things. Now, I know what you're thinking. Yes, I have this weird family member who believes in some strange conspiracy theories. Or yes, there's a lot of different conspiracy or weird theories out there, but only crazy people believe in those. But what if I told you that actually conspiracy theories, believing in some weird and strange things are actually pretty common? For example, a recent poll found that 29% of Americans believe that aliens had visited Earth. Another good example was a poll that found 11% of Americans to believe that Bigfoot or Sasquatch is real. So there is not a lot of evidence to suggest that aliens or Sasquatch is real. However, there is a good proportion of people that believe in this. But what if there is a lot of evidence to suggest that a claim is truthful? Would people believe in that claim? Well, not necessarily. For instance, a recent poll found that 27% of Americans believe in the idea that man-made global warming is a hoax and that it was invented to kind of deceive people. However, there's a lot of evidence provided by scientific methodology to suggest that climate change is being caused by humans. For instance, if we take a look at this chart here that looks at temperature changes from 1880 to 2020, we can see that from 1880 to 1920, there is really not much of a change in temperature. However, once we go from 1920 to 2020, there is a pretty drastic increase. Now, this is most likely due because of the Industrial Revolution and us pumping more greenhouse gases into the atmosphere, resulting in higher temperatures. Now, even though there is quite a bit of evidence that this is man-made or man-caused, still there is a lot of people who believe that man-made global warming is not real. So this begs one question. Can we know the world? So we can ask a couple other questions. Is the world understandable? Is there a reality? And if there is reality, can we experience that reality? I mean, these are some deep philosophical questions that not only are covered in science, but across all the board of academia. So let's ask maybe a less threatening question here. Let's ask a more simple question. Where are you right now? Now, many of you might be watching this video from your house, on your couch, maybe in a library or a coffee shop. But let's ask a different question, but very similar to this one. How do you know where you are right now? How did you able to determine where you're exactly at this moment? And a few other questions might come up, like, for instance, I might ask you, in what ways did you evaluate your environment? And you might say, well, I looked around, I noticed that I was sitting on my couch that I bought, looking at my computer, and I can, see all my stuff that I've bought from my house. So I know I'm in my living room. Or maybe you looked around and it's like, well, I saw people drinking coffee, I saw tables, chairs, and all this other stuff. So I must be in a coffee shop. And I can easily tell you that. But what if you were dreaming? Right? What if this is not real? What if this is a stimulation and you just don't know it because, well, your perception just can't tell you that information. It just makes, all your perception is doing is telling you that, hey, you perceive this to be real, but what if it's not? So it gets really deep really quick. However, in this series, we contend two important things to remember. First, we can investigate the world as understandable. And second, reality is knowable. Now, the question you might have is, well, obviously you just sent me through a physiological loophole here. I'm kind of freaking out. How can we do this? So that's the next question. How can we investigate the world or reality, right? If our perception isn't going to be able to tell us this, how can we actually look for this? Well, there's 4 different ways. First, we'll discuss assumptions, right? Assumptions are basically beliefs that people hold to be true about the world or reality, even if we don't know if they're necessarily truthful or not. Now, assumptions are pretty common in both scientific and non-scientific theories. So we use them all the time. It's a very common thing. But there are some assumptions that might be very detrimental to understanding reality. So we're going to take a look at 5 of them. So first, there is no such thing as objective truth. Now, with this one, this is the only statement I can think of that actually disproves itself. Basically, if there is no such thing as objective truth, then this statement is not truthful, because there's nothing in this world that is objectively true if you believe in this statement. Now, second, we have, if something seems real, it is real. Now, people may perceive all the time something to be real, but it doesn't make it real, right? We have to basically measure and understand it outside of our own perception, outside of our own understanding, in order to see if it's real or not. There is no reality. We make our own reality. Now, sure, we might have our own perceptions about the world, but we don't necessarily make up reality. Reality exists outside of us, and we exist probably within it. But there is a reality, and we basically claim that it can be researched and examined. Science is irrational or mystical. It's just another faith. So we're going to be talking quite a bit about science in this series, and I'm not going to give too much of a statement, but yeah, science is a methodology to learn about the world, right? It's not necessarily irrational or mystical. We try to clarify things as much as possible. Clarity and simplicity is very important, and it's definitely not just another faith, right? There are limitations and methodology issues that all scientists know about. And so those things are always discussed. It's not like we're having faith of our theories. We are basically testing our theories. And if they're wrong, they're wrong. And if they're right, they're right. And that will help us all. And our last statement is, it doesn't matter whether beliefs are true or not, if they're meaningful to you. So these statements are pretty important to know about. But if you hold these statements, they actually can be very detrimental to understanding the world. So next we'll talk about skepticism. Skepticism is basically a philosophical approach to understanding the world. So I did provide a definition of skepticism. So a skeptic is someone who demands reasonable evidence, a logical justification before granting provisional assent to truth claims. Equally important, a skeptic is also one who modifies their own beliefs if presented with more definitive evidence. So let's kind of break that down a little bit. So what are the components of skepticism? So there are 3 main things that break down skepticism. So first, a skeptic needs evidence, something to basically prove their claim to be right or wrong. Next, a skeptic needs some sort of logical justification to explain why this evidence is suggesting something to be truthful or not to be truthful. And then if they find something to be distruthful or one of their claims to not be true, they have to be able to modify their own beliefs and keep current with what is the evidence suggesting. So now that we know what the backbone of skepticism is, we need to talk about what is the essence of the skeptic position. What is the most important notions? First, extraordinary claims demand extraordinary evidence. Now, we're going to take our Bigfoot friend, for example. We've already talked about Bigfoot. So let's say you wanted to show that Bigfoot is real. Well, of course, you will see plenty of TV shows, probably YouTube videos that suggest that Bigfoot is real, and they'll show you somewhat evidence or whatever. They'll show you a little audio clip of some random noise in the woods. But we need more than that, right? We need to really prove this thing is real. Well, there's only one way to do that. Trap it. That's what you got to do. If you see Bigfoot, you must trap it and then send it to Harvard. Keep it alive, send it to Harvard, and then, Harvard will do all their testing. They'll hook it up. They'll take DNA samples. They'll make sure it's not some crazy dude in a costume, right? It's going to be absolutely, you're going to be one of the most popular people on this earth. So in other words, if of course, theoretically, if Bigfoot was to be real, I mean, I've heard he's pretty good size, so you might, want to be careful if you try this. But again, if you see Bigfoot, find a way to trap it. You're going to become a very popular person. Send it to Harvard. Trust me, your claims that Bigfoot is real would be validated. No one would call you crazy after that. So the next theory states that the burden of proof lies within the claimant. So here we have a picture of Albert Einstein, a very famous physics professor and also researcher. He basically founded the theory of relativity. Now, even though Albert Einstein now is a world-renowned scientist and everyone respects him, there was a time when most scientists definitely maybe disagreed or didn't trust that his claims were truthful. However, Albert did provide mathematical models and basically ways to prove that his theory would be correct. And years later, scientists was able to do those experiments and determine that he was correct. So, of course, given that he provided some sort of way to prove that his theory was right, he was basically able to claim that his theory was truthful. Now, the next statement says that claims must be testable. This is extremely important from the skeptic's position. So, for instance, let's take environmental science. So let's go and talk about global warming. So one thing that's important, right, is to look maybe 200 years and see how temperature changes. But what if we can look 800,000 years ago and see how changes in the CO2 level has changed over the course of time? So the way they do this is with glacier ice. They will drill into the glacier ice, and within the glacier ice is not a perfect solid. There's actually little air pockets that was been preserved for hundreds of thousands of years. Then they're able to collect samples of the air out of the air pockets and determine the amount of CO2 that was in the air at a certain time. And as you can look at this graph here, you can kind of see how CO2 levels go up and down consistently over time. It does vary, but it's pretty consistent in the amount. However, once you hit around 1950, which is right here, this little spot, you can see this dramatic increase in CO2 level. Right? So in other words, the claims that CO2 is increasing or causing the increase of temperature on the Earth, this has some profound evidence to suggest that claim to be true. Now, lastly, we have to talk about evidence must be public and accessible to all critics. Now, this is very common in the scientific perspective, and we'll talk a little bit more about this. Most science work is reviewed, right, by peer reviews, and usually it's blinded. So you don't know who's reviewing your work, but you know it's an expert in a field. So once you finish collecting your data, write all your results up and put it in a manuscript or an article, you send it off for peer review, and basically they will determine whether or not it's a good piece of work or not, or whether revisions are needed. If revisions are needed, you'll make some revisions and submit it back, and they'll determine if it's publishable or not. It's a very strenuous program, and a lot of papers are actually rejected. In fact, I would say most scientific papers are rejected a few times before they ever get published, resulting in multiple changes to the paper. And more recently, we've been promoting open science, right? Having open access to data, pre-registering our studies. So in other words, before we ever conduct a study, we tell the world what our hypothesis is and make sure everyone knows what we're doing. This has become more common with technology, right? So we're definitely going to see probably a rise in more open science projects to come, which will be really cool. So a third feature that could be very helpful is creative thinking. Basically, I like to define creative thinking using this one image. It's basically the ability to think outside of the box. If you're able to think outside of the bounds or limits already known to people, you're going to be it's going to be extremely helpful in understanding nature and reality. But we need to be a little bit more specific. In what ways can basically help us improve our creative thinking? So there's 5 things that we need to know. We got to be good at problem solving. We got to be very open-minded. We have to be able to analyze and figure out new ways to analyze stuff that we might have not been able to before. We have to be organized, and we have to be able to communicate, right? In order to be a creative thinker, you have to have these 5 major skills in order to achieve well in understanding nature and reality. So it could be a daunting task, but having these skills will basically give you a benefit and will help you out quite a bit in understanding the questions that you're very interested in learning about. Now, lastly, we have the scientific method. Now, I am going to cover the scientific method more in detail down the road, so stay tuned to that. However, just generally, we can go ahead and just mention the methodology behind science. So first, scientists typically will formulate questions about something about the world. They will form hypotheses, or basically, based off their observations or previous research, they will form what they think will happen in their research, or what the answer to the question will be. They will design a study in order to test these hypotheses. They'll collect that data using different methods. It just depends. They'll analyze the data, and then they'll communicate that to other scientists and to the world. So that is the scientific methodology. And of course, it loops back, right? Once you communicate, probably new questions are made, right? So it starts all over again. So we talked a little bit how we can explore the world using different methodologies, but why should we explore the world? Why should we investigate reality outside of our own perception? Well, first, the claims might be true. And if they are true, it could actually be pretty beneficial for us, right? For instance, scientists back in the day did not believe that rocks fell from space. However, we know that rocks fall from space quite often, and we can actually see them, very, very pretty usually flying through the air. However, if they're large enough, they can actually cause us quite a bit of harm. So it's very important for us to know about rocks falling from space. Another reason we should investigate is because misbeliefs can be dangerous and even expensive. A good example is when we have misbeliefs about people or stereotypes about people that are incorrect. Here we have a picture of protesters that are fighting for their civil rights in the 1960s being hosed down by firefighters. Obviously, this could cause the possibility of physical harm, mental trauma, and even death. People did die in these protests. Due to these misbeliefs and stereotypes, like I say, it caused these individuals to be in a very dangerous position. However, if we understood these stereotypes and misbeliefs, we could have avoided this harm. Another thing is a very booming business across the world is, into like mysticism stuff. So basically like tarot card reading, palm reading, psychic medium type stuff. This is $1 billion industry. They make a lot of money, and they can take quite a bit of advantage of people. So of course, not being able to understand the nature of reality can cause you to lose a lot of money if you're not careful. Also, not being able to understand reality might be harmful to your health, right? So here we have ear candles as the example. So I think this was more back in the 90s and 80s, but ear candles was basically proposed to help get rid of earwax or help loosen it up. So you would light a candle on fire that was hollow in the middle, and then the wax would go down the hollow tube, warm it up, and warm up your ear so you can get the earwax out. Now, the problem with that was these scientists down here, they basically found that earwax candles, ear candles were associated with actually some harm. Basically, wax can drip into your ear, especially really, really hot wax, and cause a lot of problems. So again, due to this misinformation, some people got hurt. Now, there is another reason we should investigate. Well, others may try to manipulate us. Right? We are all the time surrounded with information, right? We're surrounded from information from the media, and we're also surrounded by information from basically social media. Being able to determine whether or not someone is telling the truth or saying something factual versus kind of trying to install some beliefs in us is going to be important, right? We have to be able to navigate those waters. This is going to be essential to understanding the world, right? Is being able to determine whether something is false or not. So this is pretty much it. Here is some references. If you're on, so also I will provide these references in the YouTube description. So please take a look below. Please, a cool place to check out is the Science on Climate Change. Really cool website. It's through NASA, but it had a lot of cool figures, so I highly recommend that. But I do provide every lecture a quote, a major quote that I think defines the overall principle of what we're talking about today. So the quote for today is, "We can know the world and reality. It's possible to know. However, we must go beyond ourselves to find it." Until next time.